Question 1 is a static electricity question, and it starts off saying it's about a student walking on a carpet. And the question tells you in question 1.1 that they become negatively charged because of the friction between socks and the carpet, and you have to explain why this friction causes the student to become charged. So in this case, you only ever mention the electrons being transferred. You don't talk about anything else being transferred. So in your answer for the 2 marks, first of all, you have to get it right that it's electrons being transferred. And secondly, you have to get the direction of the transfer correct. So because the electrons themselves are negative and the student is becoming negatively charged, it's the electrons that must be moving to the student. So the 2 things, most important things in there I've highlighted. So that's for 2 marks. Question 1.2 has a diagram where they've represented their head by a sphere, the student's head, and they've reminded you the student is negatively charged, and they've shown you one of the arrows on this electric field diagram, and they've asked you to draw 3 more arrows. So to get the 1 mark, I've done my arrow drawing here. So what I've done is I've made sure that I have drawn at least 3 more arrows. I've drawn them all pointing in towards the sphere because the electric field always points in towards the negatively charged object. And I've drawn them evenly distributed around the sphere. So I've actually drawn them at 90-degree intervals around the sphere in the center. So notice that the arrows are straight lines and they touch, or they should touch, the surface of the sphere. 1.3 asks you to explain why the student receives an electric shock when they touch a metal tap. So the first thing is, if there's going to be a flow of current, there's got to be a potential difference between them. So say that first of all, there's a potential difference between the student and the tap. If they get close enough, then electrons will be able to transfer from the student, because they're the ones with the excess of electrons, to the tap. And this is basically what earthing the charge is. It's the charge has moved from a place where it was built up unusually high, and it's now evened out again. Finally, 1.4, they describe a different scenario where you have carpets with these thin copper wires running through them, and the students are less likely to receive a shock after walking on this type of carpet. And what you should say is, first of all, the inclusion of these copper wires will greatly reduce the resistance of the carpet, so the carpet will have a much lower resistance. They will also accept no resistance, but that's not quite true. And if that's the case, if the carpet's got a lower resistance, then as they walk across it, if charge starts to build up due to this friction transferring electrons, if the carpet's got a high, or if the carpet's a good conductor, if it's got a low resistance, then that charge, it's easier for that charge to leak away. So there'll be a reduced build-up of charge. In the mark scheme, all you had to mention were 2 things to get the 2 marks, and that was the much lower resistance of the carpet that included the copper wires, and the fact that this would reduce the build-up of charge on the student. That's all you needed to say for that one. That is the end of question 1.